Hey man, I just wanted to go over some of the basics of lithography here, just so you could develop kind of a basic roadmap of how these processing works. So typically you start with a substrate of some kind. You're usually going to be using silicon. Now, when you were here, you saw me I was using glass wafers, various kinds of glass wafers. I was using sapphire wafers, but most of the time you're going to be dealing with silicon. And the first thing we do is we're going to do a spin coating step. And what spin coating does is puts down a thin layer of PR or photoresist. And we typically use the RC8, which is that manual one you saw me spin coating on, as well as the ACS, which is the automated tool with the robotic arm. And that's streamlined to 8-inch specifically. And that PR then in the next step, we'll get exposed to UV light. So we naturally call this next step exposure. And PR is reactive with UV light. This is why fabs typically use yellow light instead of regular white light, because blue and violet wavelengths will still partially react the PR, which isn't great. And if we use the opposite side of the spectrum, so we use just red light, you've probably seen those rooms that they develop film in, like a photo, dark room, and that's where they specifically use red light. And it can get very dark in there, so the semiconductor industry has settled on using yellow light. That seems to work pretty well for them. And the example tools that we use to do this is the 620 and the 6200, which is the one that was down that we all complained about. And EVG is just the company that makes these. We refer to them as the 620 or the 6200. And what you do is you load your substrate with the PR into the tool, and you also load a mask that's going to sit in between your substrate and the light source. So it's going to partially block some of the UV light, and the mask is going to have the pattern that you want to transfer into the PR and to the wafer ultimately. So the mask is really what, that's the basics of really the concept of lithography. You're taking a pattern and you're going to put it into another medium, essentially using light to transfer it. And people have been doing this for thousands of years, actually, typically using inks and dyes and doing photolithography on paper to transmit an image. The semiconductor industry just uses it to do it on, semiconductors. And so yeah, you expose your wafer to UV light. And this next one, this isn't really, another step in the process. Is really just post-exposure here. Oops. It's really just like just after exposure. But basically, I've kind of labeled it as like a lighter shade of pink, where everything that saw the UV light degrades a bit, or it's like weakened, and the rest of the PR that didn't get, that was blocked or by the mask, it blocked the UV light, is still going to remain intact. And the next step, we're going to go to a develop. And during the develop, all that weakened PR is going to be selectively stripped out. And what's going to remain is just going to be the PR patterned the way we want it to, that mimics the mask, right? So this is really how we've transferred the pattern in the mask into the PR itself. And we can do this at a wet bench. You saw plenty of wet benches there when you were hanging out with us. And we can also do this in the ACS. Again, this is streamlined and it's specific to 8-inch. But now we have PR that's patterned, and that's going to act as our mask while we do our etching step. So that's the next step, is to etch. And there's two different kinds of etching. There's dry etching and wet etching methods. And they etch differently. Some examples of these tools are the RIE that you saw me use and the DRIE that Raj was explaining. And wet etching is usually like it sounds, it's in a bath. And we have like BOE is a common one, or TEMA is a really common one. And most of the time you're going to be using dry etching. And the reason for that is that these two do etch differently. And in the case of dry, it achieves this really nice 90-degree profile that we really want. And during the etch, we're etching silicon down, and the PR is essentially blocking it. Now the PR, I kind of showed it here, the PR did etch a little bit. It does etch, it's just very slowly compared to the silicon. We would say, in this case, this etch is selective to silicon, or there's high selectivity to silicon. But basically, that's how we start to change our substrate. We start to micro machine our substrate, and PR is acting as our mask now. And then afterwards, we're going to go to a PR strip, and you saw the solvents bench in there too, the big bench full of chemicals. And in the end, we're going to get a patterned wafer. Essentially, we're putting that pattern that was in the mask into the substrate itself. This is pretty cool. This is how we do, this would be like an example of a 1-layer process. We might have a 2-layer or a 3-layer. That's more common is a 2 or like a 3-layer process. But these can get, you might have one, you can have many, whatever. It's project dependent. But that's kind of the basics of how this whole thing works step by step in the process. I did omit a couple things here, just a few things that aren't really the highlights of the process, but just kind of good to understand. After you spin coat, you typically have like a soft bake, and that's just to firm up the PR. And even before that, or in many of these steps, you have a surface prep. And that just prepares, that surface so that you have good adhesion between whatever you're putting down on that silicon surface. If you have bad adhesion, like especially with PR, it'll just start to delaminate. Especially when you go to an etch, it's just not very good for processing. Similarly, after we've exposed it with UV light, we'll do a hard bake. And that's specifically to just firm it up even more and make it resistant to photochemical reactions. We've already done the photochemical reaction we wanted by exposing it to the UV light, and now we do a hard bake. So now the PR is not really reactive anymore by raising the temperature past a certain point. So soft bake, lower temp, hard bake, higher temp. And just kind of the way the nomenclature works, the hard bake really imprints the PR into the pattern that you want. So that's the basics of it. Let me know if you have any questions.